Okay, so this question is on circle geometry and it's taken from the January 2008 C2, January 2018 C2 paper. You will be examined on coordinate geometry in the linear delivery of the specification, so it's perfectly acceptable to use the modular papers to practice that. 4 parts to this question. You can see that there's 2 1 markers and 2 4 markers, so you can expect the amount of work that you do throughout this question to vary. So the question starts by telling you that you've got 2 points and they have coordinates -2, 11 and 8, 1 respectively, and there is a diameter between these 2 points. So the first part of the question asks you to show that the centre of this circle has coordinates 3, 6. So since AB is a diameter, it's effectively the same as finding the midpoint. So I'm going to start by sketching this circle, because I imagine that everything that follows is going to be easier if you have some idea of what this looks like. So let's suppose this is -2, 11, and the point 8, 1 is around about here. Doesn't have to be exact because it's just a sketch. Let's see if I can get a circle that fits on this roughly. It doesn't look too much like a diameter. Let's move it over. A little bit like this. That'll do. So there's your diameter going across here. And that's fine. So this is A and this is B. Alrighty, so the midpoint, that's the centre of the circle. So you can use the formula. I'm just going to find what is halfway between -2 and 8. So let's put this on here. The distance between -2 and 8 is 10. So these are 5. So if I just add 5 to -2, I get 3, and same for the y direction. The distance between 11 and 1 is also 10, so you've got 5s in this direction too. So I can do 11 take away 5 if I'm starting from the point A. So the centre is at 3, 6, and that will suffice for your 1 mark. Might seem excessive on the workload, but now we've got the diagram, it will help us with other parts of the question. So part B asks you to find an equation for C. Now we should know that the general equation of a circle is x minus a squared plus y minus b squared equals r squared, where AB is the centre and r is the radius. So we know the centre is at 3, 6, so we've got A and B. We just need the radius. Okay, so radius is r, and I've just labelled on the circle. So straightforward application of Pythagoras will tell you what r is. R squared is equal to the square root of 5 squared plus 5 squared. So the, sorry, that's r, not r squared. Let's leave that as r squared is 50. So the equation of the circle is then x minus 3 squared plus y minus 6 squared equals r squared, which is left at 50. Okay, nice easy 4 marks there. So I'm guessing it's going to get slightly harder, although part C is actually quite easy. Verify that the point 10, 7 lies on C. Very, very easy. So I just have to set x equal to 10 and y equal to 7, and hopefully that comes out as 50. So 10 minus 3 squared plus 7 minus 6 squared is 7 squared, so 49 plus 1 squared plus 1. Yes, it is 50. So it does lie on the circle. Alrighty, now part D. find an equation of the tangent to C at the point 10, 7, given your answer in the form y equals mx plus c, where m and c are constants for the final 4 marks. So where is this point 10, 7? It's probably going to be around about here. Okay, so let's just draw this tangent on. Something like this, so it's a very steep negative gradient. So what is the gradient of this straight line? So we need to find y equals mx plus c, m being the gradient, so let's find the gradient first. Right, okay, so we need to use the fact that the tangent is perpendicular to the radius. Okay, so inevitably we'll end up finding the gradient of that radius first. So the centre of the circle is 3, 6, and the radius connects the point 3, 6 and the point 10, 7. So let's just write that here. 3, 6 and 10, 7. I've exaggerated it a little bit. Gradient of this, rise is 1, run is 7. So the gradient of this one is rise over run, 1 over 7. So the line that's perpendicular to it will have a gradient m of minus 1 over 1/7, which is minus 7. So we were right to get this line which has a negative steep gradient of minus 7. So far we have y equals minus 7x plus c. And I know that the point 10, 7 is on that line, so that was that tangent there. So I'm going to insert the coordinates. Y is 7 when x is 10. So I rearrange and I get c must be 77. And that completes the question by writing down the equation of the tangent in the form y equals mx plus c. And we can see up here as well that 77 is going to be up high up on the y-axis, so that makes a lot of sense. Okay, please visit www.studyworld.com for more of this.